When I first started out programming, recursion was very confusing to me. What does it mean when a function calls upon itself? How does that help in solving problems? Today, I'll answer those questions and explain to you whatever you need to know about recursion in just 5 minutes. A recursive function is just like any function. It has its parameters and usually returns some value. However, what makes a recursive function distinct is that firstly, the function will call upon itself. But most importantly, it has a base case to put an end to the recursive calls. This function here essentially takes in the value n and returns the sum of all non-negative integers up to n. To see how it works, let's focus our attention on where the function is calling itself. Looking at just this line of code, it might not be so clear as to what it is trying to do, so let us expand upon it. When we pass in a value of n equals to 4 into the function, for example, we can rewrite that return statement to be as such. While we know that the answer for sum recursive 3 would be 6, the recursive function won't know that until it has been evaluated. Here, the function says, "Hey, let me pause while I wait for my friend to tell me the answer." Hence, we have to go back into our function again with n equals to 3 as the input, which adds 3 to the value of sum recursive 2. We repeat this whole process again until we reach sum recursive 1. Here, it will return 1 plus sum recursive 0. This is when our base case is triggered, as this function will pass the if condition and return 0, signifying the end of the recursive calls as it exits the loop of recursion. The answer gets passed back through each return statement as there is no need to wait for more recursive calls any longer, all the way to the front where it is consolidated. This is where it will return the value 10 as the answer. While the same result can be achieved using a for loop, we use recursion to demonstrate the idea of solving a problem by tackling its smaller subproblems. Let's take a look at another common application of recursion to illustrate this: the task of finding the nth Fibonacci sequence. From this sequence, we can observe a pattern. The next number is always the sum of the two before it. Since the next number in the sequence is interdependent on the previous two numbers, we know that recursion does just the trick to solve this. This idea can be translated in code in just one line, which is much more condensed than if we use a for loop. With the recursive call down, the only thing that is missing is the base case. Because the recursive call requires the evaluation of the n-1 and n-2 sequence, we need a base condition for when n equals to 1 and n equals to 0, which is to return n in this case. Now, if we run the function with n equals to 4, the recursive call actually constantly splits itself into two branches like so. However, the concept of returning evaluated values stays the same, and the answer gets propagated upwards from the base case back to the original function call, giving 3. To summarize, recursive problems can be solved by defining the two most important parts of a recursive function. Firstly, establish the recursive call by identifying a pattern. Lastly, define the base case which terminates the recursive loop to give you the answer. Failing to do so will cause the loop to go on infinitely, which doesn't serve a purpose other than maybe causing your program to throw an exception. On a final note, a good thing to remember is that quite often, the pattern we see is the subproblem that we need to solve. Like how we generalize the pattern in the Fibonacci sequence generator, starting small with simple cases is crucial in helping you tackle the problem. Ultimately, it is good to have that bit of faith in trusting the recursive calls to serve its functions. There isn't a need to overthink it too much. As long as you define the cases correctly, it should work as you think it would. Moving on from here, you can try to solve simple puzzles, such as the Tower of Hanoi, using recursion. It is a good exercise to put your newfound knowledge into good use. Well, that's it for this video on recursion. Don't forget to like, comment and subscribe if you want to see more of these explained in 5 minutes videos. Thank you all for watching and see you again.